Hello and welcome to Mr. Tompkins EdTech. This series of videos and their accompanying predicted papers are my best guess as to what you might expect in your next maths exam. This particular video covers AQA Paper 3. I've taken a look at what's already come up along with some statistical analysis of previous papers and drawn up a list of high frequency topics that have not yet been tested and are highly likely to appear in the coming paper. I've then selected some typical questions that you might expect to see on each of these topics and created a diagnostic paper for you to try. You'll find a link to this paper below, so why not pause the video and go and download it now. Got it already? That's great. The idea is for you to try these questions yourself first, then watch the video to mark and up-level your work. This should help you identify what topics you are solid on, and more importantly, which ones you still need to work on. In the description below the video, you'll find links to further resources on each of these identified topics. So once you've finished here, you can tap on these links to target any areas of weakness that you still might have. Also in the description, you'll find a list of further topics that may well also come up. Remember, I've only included the most likely here, but there will be others, and if you have time you should also work through those topics too. If you've not already subscribed and hit the bell, go and do it now. That way you'll be notified when I post more videos to help you succeed in your maths exams. Any questions, make sure you pop them in the comments below the video. Good luck with your preparations, and let's get into it. Hector can run 400 meters in 66 seconds. Use this information tool to show that he could run 5 kilometers in less than 14 minutes. So he can run 400 meters in 66 seconds. So what is his speed that he's running at then? We've been given this, which is distance traveled, and this, which is time taken. And I know a relationship between distance, speed and time. Do you? It's a handy little little triangle. Distance, speed, time. Those letters are there alphabetically. That helps you work out what the equation is that links those three quantities. Now we want speed, which is down here, look, and that tells me that it's the other two divided by each other. So speed, or average speed, is distance travelled divided by time taken. So that would be 400 meters in 66 seconds. So calculator, what's 400 divided by 66? That comes out to be 6.06. Reoccurring 060606. I'm just going to round it off to 6.06. So that is 6.06 meters per second, isn't it? That's the speed they're traveling in. So if we know that that's the speed, and I'm going to be running at 5 kilometers, how long is it going to take me to run 5 kilometers at 6.06 meters per second? So then I want to find out time. So coming back to my triangle, if I covered up time, then it would be distance over speed, isn't it? So that's my next calculation I'm going to have to do. So time is equal to distance traveled over average speed. Okay, so now the distance is 5 kilometers. My speed though is in meters per second, so I'm going to convert that 5 kilometers to 5,000 meters and then divide it by 6.06. What's that going to give me? Well, I've got the last calculated value still as the answer. I'm going to use the full calculated value by using the answer key. So 5,000 divided by answer, that's giving me 825. What unit is that going to be in? I had meters and I divided it by meters per second, so that is going to be seconds. 825 seconds. Now, what's that in minutes then? To convert minutes, well, to convert seconds into minutes, I'm going to divide by 60, aren't I? There's 60 seconds in a minute. So 825 divided by 60 would be what? 13.75 mins. Now that's a a decimal, isn't it? So what I want to do, if it was any other sort of questions, maybe convert into minutes and seconds. But here I just need to show that it's less than 14 minutes, which I've kind of done already. So I'm just going to finish off with that then. So I can therefore say, Hector could run it in 13.75 mins. Right, and it says Hector tries to run 5 kilometers in less than 14 minutes. Give one reason why he might not be able to achieve this. Well, fairly obviously that 5 kilometers is a lot further than 400 meters, and you kind of run out of energy after a while, don't you? You know, you can't run at a sprinting speed for 5 kilometers. You've got to go at a slower pace. So what I would say here is that Hector may tire and slow down. A is a common factor of 72 and 120, and B is a common factor of 6 and 9. Work out the highest possible value of A over B. Okay, so this fraction is going to be its biggest when A is at its maximum value and B is at its minimum value, isn't it? Okay, you'll get a bigger number if you divide a fraction by a smaller denominator. So let's take B to start with then. I think that one's going to be easier. A common multiple of 6 and 9. If we want B to be minimum, we're actually asking for the lowest common multiple of 6 and 9. Okay, so let's think about the multiples of 6 and 9. The multiples of 6 are 6, 12, 18, and so on. And 9 is 9, 18, 27, and so on. So you can see we found our lowest common multiple already. 18 is there, 18 is there. So our LCM then of those two numbers is 18. So that's going to be my value of B. What about A then? We've got A is a common factor of 72 and 120. So let's list out the factors of 72 and 120. I tend to write them down in factor pairs. So 1 goes with 72. 2 goes with, well, half of 72 is 36. I think 3 must go into it then as well. So 3 and 24, is that? 3 and 24. 4 and what? 4 and, that's got to be 18, isn't it? 5, no, 6. Yeah, 6 goes into it. 6 and 12. 7, no, 8, yes. 8 goes with 9. And look, I've met myself coming down the other way, so that's as far as I'm going to get. So quite a lot of factor pairs of 72. What about 120? We're going to have so many. So I've got 1 and 120. 2 and 60. 3 goes with 40. 4, yes, goes with 30. 5 goes with 24. 6 goes with 20. Also got a lot of factors. 7, no. 8, yes. 8 goes with 15. 9, nope. 10, yes. 10 goes with 12. And then I've got 11 in between. That's not going to be a factor. So that's all of them. Gosh, lots of factors for both of those numbers. So we want the HCF then of those two numbers. So we want A to be as big as it can be. So it's going to be the highest common factor of those two. So looking through my list, 72, no, 36 is my next biggest. That isn't on my list. 24, yeah, that's on my list. So look, 24 there, 24 there. So the HCF of these two numbers is 24. Okay, so what's the highest possible value of A over B then? Is going to be, so that was my A value, wasn't it? 24, and B is 18. So my highest value is going to be 24 over 18. Okay. which I could cancel down, but I'm not sure I need to. So it could simplify to 4/3, also an acceptable answer. Next, the diagram shows the results to the nearest percentage of a survey of 1,000 motorists. Driverless cars, good idea, 20% think it is, bad idea, 34% think it is, and not sure, 45% think it is. Interestingly, they don't add up to 100%, do they? Right, work out the largest possible number of motorists who thought driverless cars were a good idea. So actually, this is to the nearest percentage. It's a limits of accuracy question, isn't it? So if it was 20% to the nearest percentage, it means it's been rounded off to 20. Now, the next percentage up would be 21, and the next percentage down would be 19. So the ones that round to 20 are the ones that are halfway between those two. So the limits are going to be 19.5 and 20.5. They're the ones that round to 20 to the nearest percentage. So work out the largest possible number of motorists who thought driverless cars were a good idea. The largest possible is going to be the larger of those percentages then, isn't it? So I'm going to be using this upper limit then, 20.5, to calculate. Now obviously 20.5 you round up to the next value up, 21, but it still is the boundary and is still the one we calculate with. So largest possible is going to be 1,000 times by 20.5%, which is 1,000 as a multiplier, that's 0.205, isn't it? So that is 205. Now, strictly speaking, if it was 205 exactly, that would round up to 21% and not down to 20%. So I'm going to subtract 1 from that and write my answer as 204, because I know that definitely will round down to 20%. And the diagram shows a square-based pyramid and a sphere. The pyramid has a base length of 12.3 centimeters and a perpendicular height of 15.7 centimeters, and the sphere has a radius r. The pyramid and the sphere have the same volume. Work out the radius of the sphere. You must show your work in. Okay, we've been given the formula for pyramids and spheres, which is handy, so we have to remember them. Right, okay, so we know that these two shapes have the same volume, so these two things are equal in volume. Now we've got no measurements on the sphere, and we need to find out what r is. So we're going to deal with the pyramid first. Okay, so we're going to work out the volume of the pyramid, and then we're going to work backwards with the sphere formula to find the radius. Okay, so let's crack on with that then. So the volume of the pyramid is, what's that then? So the formula is down here. It's 1/3 times the area of the base times the perpendicular height. Okay, so 1/3 times area of the base times the height. Now, this particular pyramid is a square-based pyramid, so the area of the base then is going to be this area here, whatever that is, and because it's a square, it's quite easy to find. That's just going to be 1/3 of the area of the base, then is going to be 12.3 times 12.3, isn't it? 12.3 squared, and then the height is 15.7. 15.7. Okay, so throwing that into the calculator, we should be able to find out the volume fairly easily. So 1/3, I'm just going to divide everything by 3 at the end, I think. So 12.3 squared times 15.7 divided by 3, and that comes out to be 791.75 equals 791.751. Okay, and then what we're going to do now, so now we need to work out the volume, well, the radius of the sphere, don't we? So we know that the volume of the sphere is equal to 4/3 pi r cubed. Okay, so subbing in what we know that then that is 791.751 there, and we want to get r by itself, don't we, really? So we're going to have to rearrange this to make r the subject. Okay, so I'm going to multiply through by 3 and divide through by 4 pi basically. So I'm going to divide by 4 pi and times by 3, aren't I? Okay, and that will cancel those all out on the left and the right, and then I'll get 791.751 over 4 pi times 3 then, aren't I? Okay, so the 3 comes up and the 4 pi goes down, and that is equal to r cubed. Okay, and then so to find r, we're going to have to cube root that then, aren't I? If I cube root both sides, then I'll get the cube root of all of that. Okay, r is the cube root of 791.751 times 3 divided by 4 pi, all cube rooted. Right, so let's type that in. So I'm going to use the root sign first. So cube root, shift, there it is. Shift cube root, and then I'm going to use the fraction key. 791, well, it's actually my answer, so I'm just going to press answer, times by 3, and on the bottom I'm going to have 4 pi. Okay, what's that then? That's 5.7389. I'm going to round it off to 3 significant figures. I'm going to say r is 5.74. r equals 5.74. Unit, centimeters. So 5.74 final answer. The graph shows the speed of a tram as it travels from the library to the town hall. And we've got a little diagram underneath. It's a speed time graph, isn't it? So we've got speed in meters per second up the side, and I assume that's time along the bottom in seconds. Calculate the deceleration of the tram as it approaches the town hall. Okay, well, I assume that this upward part of the journey, that's it going from the library to the town hall. So you can see it's accelerating for all that period, and then it kind of reaches a peak speed, and then for the second part of the journey it's decelerating at a constant rate until it reaches a stop here. Okay, so calculate the deceleration part of the journey. Now on a speed time graph, acceleration is equal to the gradient of the line, isn't it? Now gradient is change in y divided by change in x, isn't it? In this case it's the change in the speed divided by the change in the time. So the speed changes from 6 down to 0 then, isn't it? So that's a change of -6 actually, because it's decreased. And the change in y is this distance from here to here, 85 subtract 65. Okay, which has got a difference of 20. So the acceleration is -6 over 20, which is -3 over 10, which is -0.3, equals -0.3. So if the acceleration is -0.3, then the deceleration is just 0.3, isn't it? Okay, because deceleration is how quickly it's slowing down, whereas acceleration is how quickly it's speeding up. So a negative acceleration means a positive deceleration. Right, part B. Calculate the distance travelled by the tram between the library and the town hall. Now, distance travelled is area under the speed time graph. Okay, and this case we've got two distinct areas, haven't we? We've got this one here, which is a triangle, and we've got a separate triangle here. Okay, so we've got two triangles. Another way of looking at it is those two triangles make one big triangle, don't they? So you can use the baseline all the way across from there to there, which is 85, and the height of the triangle is 6. So I'm just going to work it out as one big triangle. Half baseline of 85 and a height of 6. So half 6 is 3. 3 lots of 85. 240, 255. 255. And what's the units? It's in meters of second and seconds, so that's going to have to be meters then, isn't it? 255 meters. Part C says, what was the maximum speed of the tram as it travelled between the library and the town hall? Give your answers in kilometers per hour. Okay, so let's have another look at the graph. You can see from the graph its maximum speed is going to be that tip point on the graph, the highest point on the graph, isn't it? And we're already told what that is. That's 6 meters per second. So this question is just really about conversion, isn't it? We need to convert that 6 meters per second into kilometers per hour. Okay, so maximum speed is equal to 6 meters per second. So now we need to convert meters per second into kilometers per hour. Okay, now there are 1,000 meters in a kilometer. There are 60 seconds in 1 minute, and we've got 60 minutes in 1 hour, haven't we? So if we're going to convert this from meters per second into kilometers per hour, we're going to have to take that 6, divide it by 1,000 to go from meters into kilometers. We're also going to have to multiply it by 60 to go from seconds to minutes, and then multiply it by another 60 to go from minutes into hours. So what's that? Reaching for the trusty calculator. 6 times 60 times 60 divided by 1,000. That comes out to be 21.6. 21.6 kilometers per hour. Does that sound reasonable? Yep, it's not super fast, is it? It's probably what you'd expect a bus to be traveling at. The diagram shows a cuboid and its diagonal, and the formula to work out the length of the diagonal in centimeters is length of diagonal equals the root of a squared plus b squared plus c squared. This is one of those interesting extensions of Pythagoras theorem. So when you move from 2 to 3 dimensions, all you got to do is add in your extra length then to work out the length of the diagonal. Quite cool. So what do we have to do here? Work out the length of the diagonal where a is 8, b is 3 and c is 2. We just need to put those numbers then into the calculation and work it out. So length is equal to the root of a squared, 8 squared, plus b squared, 3 squared, plus c squared, 2 squared. So job for my calculator, root 8 squared plus 3 squared plus 2 squared. That gives me 8.77. Oh, two significant figures, 8.8. Okay, now part B then says work out the length of the diagonal in terms of A when B is 2A and C is 2A. Okay, so we've got to do the same thing algebraically now. So the length is going to be equal to the root of A squared plus B is going to be 2A, so 2A squared, and C is going to be 2A squared, like that. So how many A squareds have we got then? I've got A squared plus 4A squared plus 4A squared, which gives me 9A squared, and the square root of 9A squared, well, the square root of 9 is 3, and the square root of A squared is A. So it gives me 3A. And obviously when you square root, you often get two results, positive and negative, but in this case, there is only one solution that's valid, isn't it? It's 3A. Question 10. Eva writes 4 squared times 4 squared times 4 squared equals 4 to the power of 2 times 2 times 2, which is 4 to the 8. What is wrong with her method? Eva. I hope you haven't got your exam in a few weeks' time. Now, obviously, when you've got numbers with the same base and you multiply them together, you add the indices, you don't multiply them. So, give the correct answer. Well, it should be 4 squared times 4 squared times 4 squared is equal to 4 to the power of 2 plus 2 plus 2, which is 4 to the power of 6. Describe fully the single transformation that maps triangle A onto triangle B. Now, A and B are different sizes, so it's definitely going to be an enlargement of some sort. Now, notice that A is the larger one and B is the smaller one, and we want to find the transformation that maps the larger one onto the smaller one. So it's going to be an enlargement with a fractional scale factor. So we need to know what that scale factor is, and we also want to know where the centre of enlargement is. Now, to find the scale factor, we just need to find two sides that are the same and compare them. So let's have a look at that side compared to that one. This side is of length 3, this side is of length 1. So my triangle B is 1/3 of the original height, or the original length. So the scale factor is going to be 1/3. The next thing we need to know is the centre of enlargement. Now, the easiest way to find that is to draw on some ray lines that pass through matching corners of your shape. So let's draw one between those 2 points. And let's draw one through those 2 points as well. You can see that these ray lines are converging on the origin. I could draw a third one in as well, but actually I've already seen what the answer is. So they're all converging on this point here. So that's the centre of enlargement. So to fully describe the transformation, I'm going to say that this is an enlargement with scale factor 1/3 and centre origin. A, B and C are different prime numbers less than 20, and we're told that A equals the square root of 4B plus C. Work out two possible sets of values of A, B and C. Okay, so we've got some puzzle pieces that we need to fit together in a certain way. Let's first write down what all the primes are between well, less than 20. So the smallest prime number is 2, then 3, 5, 7, not 9, 11, 13, not 15, 17 and 19. So I've got 1, 2, 3, 4, 5, 6, 7, 8 to choose from. So these are my primes. Now I need to then pick 3 of these so they fit into that expression. A equals 4B plus C all square rooted, and that's going to have to give me another prime. Now there are lots of possible combinations of 3 things from 8 things, so let's just see if we can think it through a little bit and make the choices a little bit easier for us. Now we're going to have to take the value of B and times it by 4, so I imagine we're going to have to pick our values of B from the kind of lower end of the group. Otherwise, if we multiply them, 17 or 19 by 4, our number's going to get too big, I think. So I'm going to try picking my numbers from B at this end. Now, once we multiply it by 4 and add on C, we're square rooting. So we're aiming to get a square number, aren't we? We can pick a value of B, times it by 4 and add on one of the other numbers, and we're aiming to get a square number. So what are the square numbers? So squares, so we're aiming for 1 or 4 or 9 or 16 or 25 or 36 or 49 and so on. Remember though that a needs to be a prime number too, so I can't just have any square, it has to be of a square of a prime number. So not that one. 2 squared is, yeah, 3 squared, 4 squared, not that one. 5 squared is okay, 6 squared, not that one, 7 squared. 9 squared wouldn't be, the next one would be 121 if we're going to get that big. Okay, so let's try a small value of b to start with. Let's try b is 2. So 4 lots of 2 is 8. Now can we pick another prime number to add to 8 in order to get one of our squares that we're looking for? Okay, so let's go through. 8 plus 3 would be 11. No. 8 plus 5 would be 13. That doesn't work. 8 plus 7 is 15. Nope. 8 plus 11 is 19. 8 plus 13 is 21. 8 plus 17 is 25. Now that is one of our options. So 8 plus 17 is 25. And that would be, when I square root it, 25 square root would be 5. So that's one possible solution, isn't it? So that's b is equal to 2. C was equal to 17 and A is 5. So let's write that one in. Set 1, A is 5, B is 2, C is 17. Okay, so we've got one set done. Need to try it again and find another set. So let's try the next possible number. So try B is, let's try another small b. Let's try 3. So again, 4 lots of 3 would be 12. Now can I add another prime number on to get one of my square target ones that I'm looking for? So add in 2 would be 14. That doesn't work. Add in 5 would be 17. That doesn't work. Add in 7 would be 19. Nope. Add in 11 would be 23. Add in 13. That'd be 25 again, wouldn't it? So 4 times 3 plus 13 is 12 plus 13 is 15, is 25 again, and square root of that is 5. So again here b is 3, c is 13, making a 5. Now it doesn't matter that I'm repeating a twice, these are still 2 sets of results. So a is 5, b is 3, c is 13. Sophia is competing in a long jump competition. Her first jump is 5.25 meters. Her best jump is 8% more than this. However, her best jump is 10% lower than the winning jump. Work out the length of the winning jump. So let's just try and visualize that. I've got a 5.25 was her first jump. Her best jump was 8% above that. But as good as that one was, it was 10% less than the winning jump. So that was her best, and this was the winner. Okay, so let's work out her best jump first off. So best is going to be, well, it's a percentage increase, isn't it? So using our triangle final original multiplier, our final is what we're trying to get. Our original is 5.25 and our multiplier is, well, it's 100% plus 8%, which is 108%, which is 1.08 as a multiplier. So our final is equal to our original times our multiplier. In this case, the original was 5.25 times the multiplier of 1.08, and that gives me 5.25 times 1.08 gives me 5.67. So 5.67 is her very best jump. Okay, but the winning jump well, this 5.67 is 10% lower than the original amount. So the winning amount is, well, the winning amount subtract 10% is 5.67. So I actually want to do a reverse percentage here. So for the winning one, our final is 5.67. It's her best one. Our original is what we're trying to find, and the multiplier is going to be 100% less 10%, which is 90%, which is 0.90 as a multiplier. So using again the triangle final original multiplier, this time we are looking for the original, and we're going to use final divided by multiplier to find it. So that is 5.67 divided by 0.90, which is 6.3 meters, so 6 meters and 30 centimeters. That's a long jump. She's nowhere near it. We're told that the density of steel is between 7,750 kilograms per cubic meter and 8,050 kilograms per cubic meter. We're given that 1,000 kilograms per cubic meter is equal to 1 gram per centimeters cubed. And we're told that a solid metal object has a volume of 1,430 cubic centimeters. And we know the mass of the object is 9.6 kilograms. And the question is it possible that it's made of steel? Right, so we know that density is equal to mass divided by volume. So we've been given the volume of this metal object, and we've been given its mass. So we should be able to find its density. So density equals mass over volume. So in this case the mass is 9.6 kilograms. Okay, that's not very helpful because this is in centimeters cubed and this is in kilograms. Let's convert this into grams first. So it's 9,600 grams. Then we can make a density in grams per cubic centimeters and then convert it. So 9,600 grams divided by the volume, which is 1,430 cubic centimeters. Now, according to my calculator, that is 6.71. 6.71. That's going to be in grams per centimeter cubed. So then we can convert that into kilograms per cubic meter by timesing through by 1,000. So that is going to be 6,710 kilograms per cubic meter. Now, does that lie in our range? No, it's too low, isn't it? So it's too low to be steel. So it is definitely not steel. Too low to be steel. The ratio of number of boys to girls at a party is 3 to 4. 6 boys leave the party. The ratio of the number of boys to girls at the party is now 5 to 8. Work out the number of girls at the party. Now, the ratio of boys to girls we're given as 3 to 4 to start with. But notice in the second part we're given the ratio of girls, well, the number of parts of girls is 8, which is twice as much as we've got here. So in order to compare the two more easily, I can scale up this ratio by a factor of 2 and rewrite it as 6 parts to 8 parts. Okay, so we're told that 6 boys leave the party. And then we've got a new ratio of boys to girls of 5 to 8. Now notice that this 8 here and this 8 here are the same, so the number of shares for girls is the same, and the boys has gone from 6 to 5, so it's reduced by 1. So overall we've reduced the number of shares of boys by 1 when 6 boys left. So I conclude from that that 1 share is equivalent to 6 students. So if we then take our ratio of boys to girls and times it up by a factor of 6, we will find the number of students of each type overall. So 6 times 5, there should be 30 boys, and 8 times 6 should be 48 girls. So we need to work out the number of girls at the party, which is this number here, 48. Girls at the party, 48. Lucy makes 5-digit number cards using all of these cards: 3, 4, 6, 7 and 9. So how many different numbers greater than 50,000 can she make? Okay, so let's consider her choices. If she's going to make numbers bigger than 50,000, then there's a restriction on her first selection of her first digit card. She can only pick one of these 3 to start off with then. So she's got 3 choices for her first selection. For her second selection, doesn't matter which one of those 6, 7 or 9 she picks, she'll have 4 other choices for her next digit number. Then she'll have 3 choices for her next digit, and 2 and then 1. So the total number of selections that she's got is going to be 3 times 4 times 3 times 2 times 1, which is 72 choices. So we get to finish off the paper with a 5-mark algebraic fractions question. What joy. Okay, so we've got a complex looking pair of fractions multiplied together, and we need to show that it simplifies to a slightly nicer looking algebraic fraction. Okay, so we know about how to combine 2 fractions together normally. If I have a much simpler fraction like a over b times c over d, we would just say that, wouldn't we? We would say AC is equal to BD. We just multiply the top with top, bottom with bottom, and then we'd see if we can cancel anything out. That's exactly what we're going to do here. We're going to put all of this over into one fraction and then see if we can cancel anything. Okay, so let's start with 2w plus 4 over w squared minus 25 times w plus 5 over w squared plus 3w plus 2, and that's going to equal to something all over 1 divisor. So 2w plus 4 times w plus 5 over w squared minus 25 times w squared plus 3w plus 2. Now, can we cancel anything here? Just having a look at what's on the bottom of this, I've got we've got 2 quadratics on the bottom. Now the one on the left, this one here, is actually the difference of 2 squares, w squared minus 25. If you remember your identities, then a plus b times a minus b is equal to a squared minus b squared, which is what we've got going on here. So that part there becomes w plus 5, w minus 5. The other side of it, this bit here, is a quadratic. Can we factorize it? So does it factorize into 2 brackets? Well, if it did, it'd have a w and a w there. I have two numbers that multiply together to give me 2 and add to 3. So w plus 2, w plus 1. And that is over w plus 5 that we can't do anything with, and 2w plus 4 which we can do something with. So this part here, look. So that bit was that bit there. That bit was that bit there. That bit stayed the same, and the 2w plus 4 can become, or we can factorize 2 out of that, and it becomes 2w plus 2. Okay, so that's the blue bit. So we've kind of gone through and we've done little bits to each of those expressions. So now what? Can we cancel anything top and bottom? So I've got a w plus 2 there, which I can cancel with that w plus 2. And I've got a w plus 5 there that cancels with that w plus 5. So they all disappear. So that leaves me with 2 over w minus 5 w plus 1. Okay? So what we've done so far is we've multiplied these two things together. Now we still need to multiply that expression with this other bit on the end here, that bit. So that's the bit we're going to do next. So 2 over w minus 5 w plus 1 times 3w squared minus 16w plus 5. What's that equal to then? Well, that is 2 lots of 3w squared minus 16w plus 5 all over w minus 5 w plus 1. Now, it would be very handy if that top quadratic 3w squared minus 16w plus 5 would factorize, and I can then cancel it out with another one of my factors on the bottom. So does that break up into two brackets? Well, if it does, it's going to have a 3w here and a w there, and the numbers are going to have to multiply to 5 and add to minus 16. So if we put a minus 5 in there and a minus 1 in there, then that kind of works, doesn't it? So 3w times the minus 5 would give me minus 15w, and the minus 1 times the w would give me minus w, give me minus 16w altogether. So that does work. Right, so then can we cancel anything now? Again, I've got a w minus 5 there and a w minus 5 there, so they can cancel each other out. And I'm left with, what's left? We've got a 2, we've got a 3w minus 1 over w plus 1. Now, is that of the right form? Let's have a look back. Show that it simplifies to aw plus b, cw plus d. We're almost there. I think what it wants then, to make it into that form, I just need to multiply out the top part. Seems a bit counterintuitive, but let's do it. 6w minus 2 divided by w plus 1. Now that seems to be in the form required. The cumulative frequency diagram shows the times taken by runners to complete a half marathon. So underneath, so we've got the cumulative frequency curve, and underneath it asks us to draw a histogram to represent the data and use this table to help us. So I think we need to go through and read off the values first. Then we can populate the cumulative frequency table, and then we can fill out the table we then need for the histogram. Okay, so coming back to the diagram. So time under 100 is going to be this point here. So that's 8. Time under 120 is this point here, which I read to be 56. Time under 160 is up here, that's 100. Time under 200 up there, that's 110. Time under 300, that's the last dot on the top, and that's at 120. Okay, so then we can then work out the frequencies from our cumulative frequency. So between 80 and 100 must be all of those 8, so that goes in there. Between 100 and 120, that's going to be the difference between these two numbers. So 56 subtract 8 is 48. So between 120 and 160 is going to be the difference between 156, which is 44. Between 160 and 200 is going to be the difference between 100 and 110, which is 10. And then finally between 200 and 300 is going to be the difference between those last two numbers, which is also 10. Okay, might want to just double check that those numbers add up to 120, 10, 20, 64, 104, 112, 120. Yes, they do. Okay, so the class width is the difference between these two numbers. So 100 take away 80 is 20. 120 take away 100 is 20. 120 to 160 is 40. 160 to 200 is 40, and 200 to 300 is 100. And frequency density I get by taking frequency density is equal to frequency divided by class width. So basically I have to divide my first column by my second one, and that would be my frequency density. So 8 divided by 20 is 0.4. 48 divided by 20, 2.4. 44 divided by 40, 1.1. 10 divided by 40 is 0.25 and 0.25. Okay, so now I've got all the information I need to draw my chart. So my first bar is going to be from 80 to 100, and it's going to have a height of 0.4. So I've not been given a scale for frequency density up the side here. So the first thing to do really is then decide what the increments are going to be up this scale. So I've got to go up to 2.4. That's my largest value. So that's going to have to be at the top of my scale. Counting up, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 squares. So, and I want to go up to 2.4. So if I go 2 squares, so 1 square is, so if I take one little square, oops, if I take one little square is 0.2, 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2, 2.2, 2.4. That seems to fit in nicely. Okay, so my first bar was frequency density of 0.4 and going from 80 to 100. Okay, now the second bar goes from 100 to 120 and has a height of 2.4. Okay, now the next bar goes from 120 to 160 with a height of 1.1. So notice that one is a bit wider than the other two because it represents a wider class width. The next one is running from 160 to 200, has a height of 0.25. And then finally, well, I've just noticed this one's wrong actually. That should be 10 divided by 100 is 0.1, isn't it? So correcting that, then 200 to 300 at a height of 0.1. So that completes my histogram. The equation of a curve is y is equal to x squared plus 14x plus 52. By completing the square, work out the coordinates of the turning point you must show your work in. Right, so if I want to take y equals x squared plus 14x plus 52 and rewrite it in completed square form, I take this number here, the coefficient of x, and I halve it, don't I? So 14 divided by 2 is 7, and that is then the thing that I use in my bracket. So y is going to be equal to x plus 7 all squared. That is going to be my replacement for x squared plus 14x. But x plus 7 all squared is actually x squared plus 14x plus 49. So I've introduced 49 more into my equation I had to start with, so I need to take it away. Plus I've still got that 52 there left over from earlier that I didn't use. Okay, so then just tidying that up, y is equal to x plus 7 all squared minus 49 plus 52 is plus 3. Okay, so when is this equation at its least? It's at its least when this bracket here is 0, so then we've got 0 squared, and that occurs when x equals -7. So turning point is going to be when x is -7. Now if x was -7, that bracket would disappear and it would just leave you with 3. So y is equal to 3. Okay, so then the coordinates then are -7, 3. I've been given two functions of x, f of x equals x squared plus 1 and g of x equals x minus 5. I need to show that f of g of x is that expression there. Now f of g of x means take g of x and put it inside f of x, which basically means wherever I see x in my f of x expression, like here, I need to replace it with that expression. So I'm going to take my x squared plus 1 and insert x minus 5 in where I see the x. Okay, and then I need to multiply that out, x minus 5 all squared. Now last time I did this, I did it the long way, but this time I'm going to use the identity. If I've got a minus b all squared, then that is a squared minus 2ab plus b squared. This is a very useful identity to remember. It makes it multiplying out these things a lot quicker and easier. So that gives me x squared minus, so 2 times a times b in this case would be minus 10x plus 25 plus 1. So then just joining those last two things together gives me that. So done. Now part B says solve fg of x equals gf of x. Okay, so we've already worked out what fg of x is. What's gf of x? So gf of x is equal to, well, we take our function of f of x and we feed it into our g of x. So this time round our x is here and we're going to replace it with this expression. So that is going to sit where that is in there. So I'm going to get x squared plus 1, my x, take away 5, which is x squared minus 4, isn't it? Okay. Now I need to solve fg of x equals g f of x. Now we just showed that fg of x is x squared minus 10x plus 26. So x squared minus 10x plus 26. And we now know that's the same thing as x squared minus 4. Okay, so our x squareds cancel, and we are left with minus 10x plus 26 equals minus 4. Okay, so I'm going to move the minus 10x to this side, and I'm going to move the minus 4 to this side. So that gives me 26 plus 4 is 30 equals 10x. So x equals 3. The diagram shows a logo. We're told that ABE, this one, is congruent to DCE. So these two triangles are the same area. Okay, and we're told that BCE is a sector of a circle. Okay, so what do we need to do? Show that the area of the logo is 510 centimeters squared to two significant figures. Okay, so we're going to have to work out the area of one of these triangles. We can use the fact that it's congruent to double it up and then find the other one. Plus we need to work out the area of the sector. Right, do we have all the information we need? Not really. To work out the sector, I'm going to have to work out the radius of that circle. I can easily work out the area of the square. That's going to be the triangle. That's going to be no problem. I can just use trigonometry to do that. But I'm going to have to then use trigonometry again to find r, so I can work out the radius, and so I can then work out that sector. That's going to be the trickier bit. Because it's a non-right angle triangle, so I think we're going to be using cosine rule, aren't we? So it's going to be quite long. For 5 marks, that's a lot of work. Okay, let's get busy with it then. So the area of a triangle, area of the triangle is going to be half AB sine C. That's our formula for an area of a triangle using trigonometry, which is our two sides and our included angle. So it's going to be a half A, which is 26, times B, which is 15, plus our included angle sine 38. What's that then? So 0.5 times 26 times 15 times the sine of 38. I make that 128.053. Okay, I'm going to give my final answer to, oh actually I don't need to, it's only to two significant figures. Let's just round it off then. I'll leave it like that. Okay, so that's the area of one of my triangles. So then my sector, I'm going to need to know r first. So I need to know that radius. Now I was saying earlier about sine rule and cosine rule. Sine rule is about opposites, and the cosine rule is either two sides and an included angle, which has got here, look, two sides and an included angle, or it's having three sides and wanting to find an angle. So I know that this is going to be the cosine rule this time. So can you remember the cosine rule formula? The cosine rule formula says a squared equals b squared plus c squared minus 2bc cos a. Now that's the way around you use it to find a length, which is what we're trying to do here, isn't it? Okay, so in terms of this diagram, our r squared, our a squared, is going to be our two lengths squared, so my 26 and my 15. 26 squared plus 15 squared minus 2 lots of 26 and 15 cos the angle, which was 38. So calculator time. 26 squared is 676. 15 squared. You can also just type this in all in one go if you want as well. Minus 2 times 26 times 15. 780. Cos 38. What's that then? 676 plus 225 minus 780. Lots of the cosine of 38. I make that 286.3. Remember that's r squared, so r is going to be the root of that. So square root in my answer. I make that 16.92. Always good just to check for sensibleness. Does that look right in that diagram? 16.92, a bit under 17. That looks good. Okay, so now we found R, we can then use it to find the area of that sector then. So our area of our sector is going to be the fraction of the circle that we've got. So the angle is 108, so it's going to be 108 360ths of the area of the circle, which is pi times r squared, which in this case is going to be 108 over 360 times 16.92. I'm running off the side of the page. 16 times 92 squared. So let's type that into the calculator. 108 divided by 360 times by pi times by our last calculated answer squared. So I make that 269.88. Where'd I have to write the answer? Oh, I just need to show it. I'm running out of space though, aren't I? Okay, I can still squeeze it in, I think. So then total area is going to be 2 times the area of the triangle plus the area of the sector, which is 2 times 128.05 plus 26988, which is equal to, I'm going off the bottom of the page here, which is very naughty, shouldn't do that in the exam, so plus 2 lots of 128.05, 525.98. What am I aiming for? Show that the area of the logo is 510 centimeters squared to 2 significant figures. Well, I get 530 to 2 significant figures. Okay, I'm not quite getting the answer that I was meant to here. I make that 520 something, where the answer here says 510. So I'm just going to go through and double check all my work. And I've just realized that I've made a mistake here when I read the calculator value. I did put the right thing in the calculator, but for some reason I misread the output, and it should be 120.05 there. Now luckily that doesn't change any of my other answers all the way down to this point here. That one there should be 120.05. So let's just type that in again. 2 times 120.05 plus 269.88. Oh, that's much better. That gives me 509.98,
which definitely does round off to 510 to two significant figures. Okay, so what's the units? Centimetres squared, isn't it? So we have got there. I just made a bit of a silly mistake here. I misread my calculated value. So that is actually a good thing about these sorts of questions, where you have to show that that calculation is equal to a particular number, because you can error check whilst you're in the exam, like I just did then. So happy I've got it right now. Let's move on.
In a class there are n boys, a total of 25 students. 2 of the students are chosen at random. The probability that both students are boys is 7 over 20. Work out the value of n. Okay. Right, so a quick tree diagram to think about this. Let's say you pick a student, and it's either a boy or it's not a boy. Okay, and then if you pick a boy, you can have another choice, and it's a boy or it's not a boy, or it's a boy or it's not a boy if you chose it the other way around. Now, there are n boys and a total of 25 students, so the probability that you picked a boy first time is going to be n over 25. Okay, and then so the probability that you picked a boy the second time, well, you've got one less boy to pick from, and you've got one less student to pick from, so it's n minus 1 over 24. Okay, so if you wanted to pick the probability of boy, it's going to be this route through the tree diagram, isn't it? It's going to be up here and then along here. Okay, so that would be the probability of n over 25 times n minus 1 over 24. Okay, and we know that the probability that both students are boys is 7 over 20, so we know the answer is 7 over 20. Okay, so we want to find out n basically. So what we've done here is we formed an equation in n, which we now need to go on and solve. Okay, right, so combining those two fractions together, we're multiplying, which is just numerator times numerator, so that's n minus 1 on the top, denominator times denominator, and 25 times 24, that comes out to be 600. So n minus 1 over 600 is 7 over 20. So what could we do here? So we cross multiply that 600 over, so I'm going to get n minus 1 is 7 times 600 over 20. What's that then? So 600 times 7 divided by 20, that comes out to be 210. So n lots of n minus 1 is equal to 210. Okay, right, so I think what we're going to do here is we're going to have to form a quadratic and solve it then. So multiplying out the bracket, I'm going to get n squared minus n, and then bringing the 210 over back over to the other side, minus 210 is equal to 0. Okay, does it factorize? It'd be handy if it did. 210, what could be factor pairs of 210? They're going to have to be quite close together. Well, they have to be like 1 apart. Can I think of two numbers 1 apart that multiply together to give me 210? Okay, well, the root of 210, root 210, that's 14. So what about 14 and 15? 14 times 15? Yeah, that's 210. So I'm going to say that I've got 14 and 15 in here then, and then n and n. It's minus 1, so the 15 needs to be the minus 1, and then the 14 is going to be positive. So I've got n plus 14, n minus 15, giving me solutions that n is minus 14 or n is 15. Now, one of those solutions makes absolutely no sense. I can't have negative 14 students or boys. That makes no sense. So it has to be that one there. Okay. Now, sometimes when you form an equation that's a quadratic and you go on and solve it, you know, whilst your answer might be a solution to the quadratic, it's not necessarily a solution to the actual problem that you're modelling with a quadratic, in this case the number of boys. So the number of boys here has to be 15. So number of boys, n equals 15. That's the only answer. Okay, job done. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here.
If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.